We're counting down 10 moments that fundamentally reshaped the world you're standing on. From violent cosmic collisions to breakthroughs that rewired civilization overnight, each entry triggered changes so massive, nothing afterward was ever the same. Some built new worlds, others destroyed them. And the force behind number one is the last thing you'd expect. It starts 4.5 billion years ago with a planet that didn't yet exist. In the 10th place, about 4.54 billion years ago, a collapsing cloud of cosmic dust and gas sparked a violent accretion process, assembling a molten, newborn Earth. Heavy elements like iron and nickel sank into the planetary interior to forge a massive metallic core, while lighter silicate rocks floated upward to form the mantle and crust. Intense, relentless volcanic eruptions continuously outgassed water vapor and carbon dioxide, establishing the planet's first primitive atmosphere. As the chaotic magma oceans slowly cooled and the rocky surface stabilized, liquid water finally condensed from the sky, pooling into the very first global seas. This colossal foundational transformation laid the physical bedrock for every major planetary shift that followed. Number 9. Shortly after Earth's birth, a Mars-sized world named Theia collided with the young planet in a grazing cosmic crash. The impact vaporized both bodies, launching a massive cloud of molten debris into orbit. Over time, this ring of hot rock coalesced to form the Moon, leaving a geochemical fingerprint in lunar samples that perfectly matches Earth's mantle. This violent union did more than light up the night sky. The Moon's gravity stabilized Earth's axial tilt, preventing wild climate swings, while its gravitational pull created powerful tides that churned the early coastal seas. By establishing a predictable planetary rhythm, this cataclysm transformed a chaotic, hostile rock into a stable and highly habitable world. 8th place. Deep within the ancient pitch-black oceans of a young Earth, a spark ignited that would forever alter the cosmos. The transition from non-living chemistry to self-replicating biology. While scientists debate whether this event began around scorching seafloor hydrothermal vents, rich in mineral gradients, or in sunlit shallow pools undergoing wet-dry cycles, laboratory tests confirm that life's building blocks readily assemble under early planetary conditions. The physical proof of this milestone is etched into fossilized stromatolites dating back nearly 3.5 billion years in Western Australia. These ancient microbial mats mark the moment Earth changed from a sterile volcanic rock into a living, breathing world, initiating an unstoppable biological chain reaction that would eventually reshape the entire globe and fuel the rise of all future complex life. Number 7. Roughly 2.4 billion years ago, microscopic cyanobacteria pioneered oxygenic photosynthesis, initiating the Great Oxygenation event. Instead of flooding the sky instantly, this reactive gas accumulated slowly over millions of years. Deep in the ancient oceans, dissolved iron reacted with the newly produced oxygen, precipitating onto the seafloor to create massive, striped banded iron formations. At the same time, shifting sulfur isotope signals in ancient sedimentary rocks recorded the permanent end of a fully oxygen-free world. This global chemical shift completely rewrote the atmosphere, turning a toxic sky into a protective shield. By replacing low-energy anaerobic pathways with aerobic metabolism, this event supplied vastly more energy for living cells, enabling larger, higher-energy bodies to colonize new ecological niches and build complex, global ecosystems. 6th place. Spanning over 180 million years, the Mesozoic era underwent a monumental planetary restructuring. From about 252 to 66 million years ago, the supercontinent Pangaea fractured, drifting apart to isolate continents and carve out new evolutionary paths. Dinosaurs seized these emerging habitats, diversifying into colossal sauropods and fierce theropods that completely dominated terrestrial ecosystems. Meanwhile, in the warming oceans, massive ichthyosaurs and long-necked plesiosaurs ruled the open waters. This era produced legendary giants, while also triggering the rise of early birds and the first flowering plants, altering Earth's forests forever. This prehistoric chapter proved how continental movement could fuel a vast explosion of land-dwelling life. Number 5. 66 million years ago, a 10-kilometer asteroid struck the Yucatan Peninsula at 20 kilometers per second, carving out the 180-kilometer Chicxulub crater. This cataclysm released energy equivalent to millions of nuclear weapons, instigating a sudden, violent global reset. Physicist Luis Alvarez and geologist Walter Alvarez discovered the smoking gun, a thin clay layer containing iridium concentrations up to 160 times higher than normal, marking the boundary where dinosaurs disappeared. The hypervelocity impact vaporized target rocks, throwing sulfur, dust, and billions of tons of soot high into the stratosphere. This dense shroud blocked sunlight, halting photosynthesis and triggering a devastating impact: winter. As global temperatures plunged, food webs collapsed from the bottom up. While non-avian dinosaurs perished, tiny, resilient mammals survived the darkness, eventually emerging to occupy the vacant ecological niches and inherit a transformed planet. Number 4. Fourth place. Beginning roughly 2.6 million years ago, a massive atmospheric shift plunged the planet into a series of intense glacial cycles. Over vast spans of time, towering sheets of ice advanced and retreated, locking up so much water that global sea levels dropped by over 120 meters. This drop exposed the Bering Land Bridge, creating an open highway for animal and human migrations. Massive glaciers carved immense valleys, altered the path of major rivers, and reshaped the continents. Locked inside ancient Antarctic ice cores, trapped air bubbles preserve a direct record of these historic temperature swings and greenhouse gases. Forced to adapt, countless species evolved thick coats, traveled thousands of miles, or vanished entirely, restructuring global ecosystems into the modern world. Coming to the top 3, the rise of Homo sapiens transformed our planet as evolutionary change became deliberate, cultural, and cumulative. Around 75,000 years ago in Blombos Cave, South Africa, early humans left behind engraved ochre and pierced shells, signaling the birth of symbolic thought and shared meaning. Complex language allowed groups to plan, coordinate, and pass vital knowledge across generations, while refined tools vastly multiplied human physical power. This cognitive foundation set the stage for the agricultural revolution 12,000 years ago. Cultivating crops triggered widespread land clearing, altered global vegetation, and sparked a dramatic demographic surge past 50 million people. As early urban centers like Catalhoyuk grew, they concentrated resources and environmental impacts into organized networks. For the first time in geological history, a single species evolved the capacity to consciously alter the global biosphere, turning human curiosity into a primary planetary force. In second place, the digital revolution accelerated human impact faster than any previous transition in planetary history. It began with early electronic computing in 1946, when the massive ENIAC machine proved that complex calculation could be automated. This breakthrough laid the foundation for the 1969 launch of ARPANET, which sent the world's first packet-switched digital messages. Together, these systems rapidly evolved into the global internet, orbital satellite constellations, and advanced data-driven medicine. Today, orbital sensors track global temperatures and atmospheric shifts in real time, while artificial intelligence processes petabytes of environmental data. This interconnected digital network turns human curiosity into a planetary-scale feedback loop, expanding our ability to monitor, understand, and manage Earth's ecosystems. However, this explosive technological growth also consumes vast resources and drives unprecedented energy demands, placing immense pressure on the modern biosphere as we guide the planet into an uncertain, hyper-connected future. And finally, in first place, human curiosity stands as the ultimate force shaping our planet's future. It is not a single geological event, but the active spark that directly unites science, history, and technology, turning vast cosmic mysteries into genuine understanding. Every major milestone on this countdown, from examining 3 billion-year-old fossilized microbial mats in Australia to launching the modern digital network, was driven by this persistent desire to ask why. As we look ahead to a rapidly changing tomorrow, our ongoing search for answers will ultimately decide what our planet becomes next. Stay curious and subscribe now. Across all 10 epochs, one truth emerges. Earth is a masterpiece of constant reinvention. What began with raw physical chaos is now driven by human curiosity. We are no longer just passive survivors of planetary history, we are the authors of its future. Subscribe to explore more of our incredible universe.